Okay, on this problem, these things here, those are square roots. So we're looking for numbers that when we square them, will give us those answers. So it does help if you know some of your perfect squares, and I usually tell people you should really know the first 10 because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, that's 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. So when I'm looking at the square root of 75, 75 is somewhere between 64 and 81. So 75 is not a perfect square. However, hidden within 75, there is a perfect square factor. 75 is actually a 25 times a 3. But because the 75 is underneath the square root sign, both the 25 and the 3 should also be underneath square root signs. And the trick to this is you can actually take the square root of the 25, that becomes a 5, and you have freed it from radical land. Unfortunately, the 3 is trapped under the radical and you can't do anything with him. Okay? Now that's the number part. The get a different color here, a blue. The x to the 6th, okay, that's a little different because it's a variable. And there's a shortcut trick on this. If I have an x to the 6th, that was actually an x cubed that got squared. If you remember your exponent rules, if you have a power raised to another power, which I do here, I have a 3 raised to a second power. So you multiply 3 times 2, and that's where this 6 comes from. I'm just kind of working backwards. So what I'm seeing here is, give me my pink pen again. I'm taking the square root of an x cubed that got squared. And so your square root and your square cancel each other out. This thing here and that thing there cancel each other out. So what you're left with is just the x cubed. Now the shortcut is just take 2. If I look at it as the square root of x to the 6th, I see that as an x to the 6 divided by 2, which is x to the 3rd. That's the shortcut, just dividing it by 2. Now, that x to the 3rd, I actually took him out of the radical, so he actually needs to get stuck right there. He needs to go between the 5 and the square root of 3. So this first thing here, let's see, so many colors. Oh, green. Okay, so this guy right here, this whole thing simplified to be 5x cubed times the square root of a 3. And then there's a plus sign right here, so I still have that. And now I need to do the other one. Okay, so starting again with the number, which is a 48. Let's see, before I use red, how about we use this color blue? Okay, 48. 48 would be somewhere between 36 and 49. So 48 is not a perfect square. But hidden within the 48 is a perfect square because 48 is 16 times 3. And I can take the square root of 16, but not the 3. The square root of 16 is 4. I also still have the square root of 3. That stays there. And just like before, here's another x to the 6th. So I'm going to get another x to the 3rd in the middle there, just like the last one. So I have a 4x cubed square root of 3. Okay, now I'm going to rewrite this all in black so I can use another color to show you something else. Okay. All right. Okay, what I have here are like terms. I have 5 x cubed square roots of 3 plus 4 x cubed square roots of 3. So that's going to give me 9. Whoops, did not mean to go with that color. 9 x cubed square roots of 3. Let me go back to my green. You're just going to add your coefficients. 5 and 4 gives me that 9, and the rest of it just stays the same. It's like saying, this is no different than when you would take a problem like 2b plus 5b, that's 7b. You add the 2 and the 5 to get the 7, and then the b here matches the b there, and that's just how many b's you have all together. So I have 9 x cubed square roots of 3. Now the fun part is typing this in. Okay, I'm definitely going to use the equation editor instead of doing this up here. It says you can write exponents with the little caret button. It's that little arrow pointing up, but it doesn't look mathy to me. Like, then they tell me I can write SQRT instead of square root. No, I want it to look like this. I want it to look like that. That's my answer. Oh, that's SQRT business. So I'm going to hit the equation editor. Boop. Okay. Click on the box. I've got 9. And then I've got, let's see, click on this and do the exponent and put in an X where that A is. So back it up, X. Scroll up to the exponent and delete that and do a cubed. And then scroll over to the right to drop this down again, and then go back up here and click on him, and I need a square root. So this is the square root, and just type a 3 in there. Isn't that what it was? 9x cubed times the square root of 3. Whoops, sorry. And how did I do? Ta-da! And the crowd goes wild. Ah, yeah. Okay. I hope that made sense.